There was a homework due Monday. The last homework is due Monday. So we're almost to the end of the semester. I'll comment on the final exam, which hasn't been written yet. I plan on writing that on Saturday. So it'll be a slightly different format than the midterm because the midterm is take-home. I could ask you to write programs and assume that you would write the program and compile it. We could do that. In class, even though the exam is going to be open book, no notes, closed notes, I'm not going to expect you to write programs. Certainly not write actual Java code on a piece of paper, but there also won't be any actual programming part. So even though there are computers here, we won't use them for the exam. So the first half, I like the two-part exam sort of thing. So the parts will be essentially the same. Part 1 will be general concepts, and then part 2 will be applications, I think I called it. So part 1 be mostly regurgitate general philosophical concepts that I've rambled on about in class and that the book has talked about. Things like exceptions, abstract classes and interfaces, that sort of thing. I won't specifically ask about topics that were on the midterm, but because of the very linear nature of this class, if you don't know topics from the midterm that were on the midterm, you may have difficulty correctly answering questions on the final, just because the newer material bases itself on some of the older material. The second part, on the midterm, there was one pseudocode question, one implement this class question, and one solve this problem writing a program to do it question. The spirit of the questions will probably be the same on the final. There will definitely be a pseudocode question. Take this problem, break it down into smaller problems, and tell me how you would solve it. And I liked the way it worked out on the midterm, where there were parts that we hadn't talked about. So there will be something about that question that we haven't specifically talked about. In that question, there was something about file I/O, which conveniently we're going to talk about today. For the final, I don't know what we'll talk about. It'll probably, well, I don't want to say probably, but it might be interesting to kind of give you a sneak peek of where you're going in the data structures class. So in that case, it might be something like you need to implement some particular set of objects as some sort of data structure that makes sense in the real world. I don't know how to do that yet, but I know that I will need to figure out this problem. So that's one of my subproblems that I'll mention. Here's a subproblem with the larger problem. I'll solve that some other way. Let's see what else. There will definitely be a class, a build a class oriented question, but it won't be write Java code for it. It'll be probably along the lines of draw a diagram. So we didn't specifically talk about UML, but so I won't take off points if it's not exactly UML. The book mentions UML, and for all of its class illustrations, they use UML, I believe. But name of class, the data it stores, the accessors and mutators, what's read-only, what's public and everything can see and everything can change, and the operations that you can do with that particular class. And for that, there will probably be some inheritance piece. So you should have some lines between classes indicating this class is an extension of some other class. taking an example from the homework assignment that I'm losing track. Either was due Monday or is due next Monday. Extending car and making Mustangs and PT Cruisers and stuff like that. So you'd have a car up at the top, and then you'd have lines drawn to PT Cruisers and Mustangs and Crown Victorias and Outbacks, whatever. And then the last question was solve a problem using Java code. So kind of tying it all together. Because that was more a solve a problem writing code in Java, which we can't really do if we're not writing code in Java. It might be something along the lines of there might be two of one of the other types of questions and not that big question at the end. Or there might be two pseudocode questions and two of the other kind of questions, depending on how the points work out and how big the projects end up being. But likelihood, and now that I'm saying this sounds like a good idea, probably two problem solving using pseudocode questions and one drawing illustrations of classes that you would use to implement some interface. Questions?
Or
this already. I will ask that the monitors be turned off. So, open book, closed notes, closed phones, closed. Unless you have an ebook, then you can show me what you're using the ebook on, and I'll keep an eye on you, make sure you're not going off to the internet. Does anyone have an ebook? Is that a concern? Okay, cool, that makes it easy. So, open book, that's it, no phone a friend. There is ask the professor as long as it's not the exact question that I'm asking you.
Could I divide the book as a bookmark?
You can do whatever you want to the book. I guess technically, if I don't put any restriction on that, you could write all your notes inside the book, which... Sure. I mean, basically, the idea is I'm trying to make it as realistic as possible in terms of a real programming situation. So, programmers sometimes have shelves of books, sometimes have PDFs that they've acquired. We'll leave the methodology up to a big question mark. Friends, other people who have acquired them illegally. Who knows? Programmers have access to a bunch of books. Programmers may at one time have had notes, but they have probably since lost them. I know that's the way it is with me. I know where the books are because they're held together very well and are very prominent on a bookshelf. Pieces of paper do not fit on bookshelves very well. I guess technically in a real-world situation you could phone a friend, collaborate, but in the interest of testing you and only you, we can't really have that. Otherwise, we'd get one grade for everybody in the room, and that wouldn't be fair to everybody. And that's a week from today. Today does not feel like a Wednesday, but that is a week from today. Before we get to that point, we have two topics, file I/O and recursion. Both topics will be on the exam, even though I don't remember if file I/O. No, neither of those topics are used in our program. So I can tell you that the question on recursion will be, and you can write this down, this is exactly what the question is going to be, what is recursion? The question on file I/O, I don't know what the question on file I/O is going to be yet, but it will probably be something similarly high level, maybe a little bit more in depth, because I can't really say what is file I/O. That's a very broad question. probably something relating to how is doing file I/O similar to all the other I/O that we've been doing in this semester. That's a pretty good question. And we'll find out that everything we need to know to do file I/O, with some very small exceptions, we've already learned. It's just a matter of how we use that in a different context. Joel, you had a question?
Yes. How long do you get for this class?
It is... I was going to say exactly like the midterm. We didn't have a midterm in class. So that is a fair question. What I intend for the timing of the exam is that the first half of the class will be exam time, and the second half of the class will be talking about the exam. Because from my perspective, in the interest of you guys learning, it's great that you take an exam, you get a grade back, but that doesn't really tell you where you're struggling, what you did well on, what you need to work on in preparation for 1450, what you need to keep in mind when you use Java in the real world, because you're going to use Java in the real world, right? So I want to have a segment of the class where we go over the exam. You won't get your grades back that day because I can't grade whatever it is, 18 exams. I think there are still 18 people enrolled in the class. 18 exams in 15 minutes. It doesn't work.
So you're talking like an hour and 15 minutes or something?
Yeah, hour and 15 minutes to do the exam, and then hour and 15 minutes of discussion. I will make a decision at the hour and 15 minute mark based on how many people still are working on the exam as to whether I'll extend that. Because I don't want... the discussion is not going to take an hour and 15 minutes. Guaranteed. I've found that when usually while students are taking the exam, I write the key. Kind of a double check to make sure that I didn't make the exam too hard. The time it takes me to write down answers for the key, especially with short answer questions, is about the same time it takes for me to explain my answers in front of a class. And that's usually a third to a half the time that students take. I was really terrible at statistics. So with the exception of the standard, beyond 3 standard deviations on the long side, everybody finishes within that time limit. So if it takes everybody an hour and 45 minutes, or 90% of people to finish, I'm okay with that. I'll let you have an hour and whatever I said, 45 minutes, and then the remaining time we'll talk about the exam. If most people are finished by an hour and 15 minutes, then we'll end the exam and we'll talk about it. Any other questions on the exam? Okay, so today we're talking about file I/O. Ten 4 and 10.5 talk about binary files. Binary files are, there are techniques for dealing with, they don't give a name to the other kind of file, plain text files. I don't remember where that sentence started. There are techniques that are used for reading and writing to text files. There are techniques that are used for reading and writing to binary files. There's a lot of crossover between the two. The issue comes in that reading and writing from a text file, you're reading and writing characters and strings, whereas reading and writing from a binary file, that restriction is lifted. Who knows what you're reading and writing? It's up to you and writing your program and making sure that the only things that read and write those files follow your format, so that you can make sure that when you read a particular piece of a file out, it still makes sense. So it's a more complicated topic, but more complicated in terms of error checking mainly. So we won't talk about that in class. You have hopefully already read about that in the book, though I think I put that in parentheses. So if you haven't read about that and you're interested in binary files, check out those sections. It's useful if you have to deal with binary files. I'm trying to think of binary files that I know of. Images, videos, sound stuff. Basically these days anyway, the common file types that are binary files are things that are sampled, which basically means pictures, movies, sounds. These days, everything else is pretty much a text file. And I can say that even though if you tried to open up a Word document in Notepad or something like that, it would look like complete garbage and it would look like a binary file. Those file types are actually a zip file of a directory of a bunch of text files. So once you unzip that file, change the extension to .zip, unzip it, you get a directory, and then you can read and write those files just like text files. Usually those file formats have some added markup, which is called XML, which is not talked about in this book. XML is kind of it's a markup language. That's in fact what XML stands for. Extensible markup language. Basically, it's not just text, it's given some structure, and there's some information built into the file, built into the text that's in the file, that determines the structure and purpose of the data. A very common example on OS X of XML is the plist, or property list. It's a more standardized version of XML for configuration information, basically key value pairs. For this specific option, here's the value. Right, so text files. When Java finally standardized its method of dealing with I/O, it settled on something called streams. And this is something that it borrowed from C++. And a stream, well, let's start with a stream in real life is a trickle of water, or hopefully slightly larger than a trickle of water. In Colorado, it's a trickle of water. In Pennsylvania, it's something slightly smaller than a river. But the behavior is still the same in both Java and in real world. Something comes in from somewhere else, higher elevation, and travels toward lower elevation. With streams in Java, that idea of directionality is maintained. And also the idea of once it goes past you, it's gone. So, why are streams useful? Well, let's start at the beginning. Why are streams useful for dealing with keyboard input? Little secret, system.in is a stream. It's a reader on a stream. But it's basically a stream. So, when you're typing keyboard input, you type something, you expect the program to deal with it, and then it goes away. It is no longer at the keyboard. You're done with that. You type something else, program deals with it, you're done with that. So you can think of it also like Normally, I think I was dating myself here, but I think everybody here would be okay with it. The cassette tape. So I don't know if you're familiar with how a cassette tape player operates, but there's a read head, and there's a write head as well. But the tape goes from one spool to the other spool and passes by the read head. So a stream is basically a cassette tape where things can only go one direction. You have a play, that's it. You don't have a rewind. You can have a fast forward, but that's essentially like play and you don't have the speakers connected. And in terms of computer streams, that's usually considered a skip operation or something like that, or a seep. And you have the same thing with a stream that you can write to. Tape still goes one direction. You still have no rewind. And as you send something to the write head writes it to the tape while the tape is spinning, and as soon as you're done, it stops. It doesn't just keep recording when you don't have anything going in. So in this way, you can construct a file from first character to last character, and you can read a file from first character to last character. And system.in, keyword input, operates exactly that way. It starts out, until we type something at the console, in Dr. Java, it's in the interactions pane. There is nothing there. So when we call our scanner object.nextInt, it says, I need an int. Give me an int. And that's, Dr. Java kindly waits for us and shows that little box, and we can type something in. So those are the first characters that get put in. We can keep doing that. Onward and onward. And the distinction between streams for text files and streams for binary files is that each thing that goes through the stream for a text file is a character. That's the most elemental thing. For a binary stream, it's a byte. It's binary data. It doesn't do any interpretation on it. Doesn't try to convert it into an actual character. So you can store numbers directly in a file, not as the characters that make up those numbers. Another thing that's useful with a text file versus a binary file is that since a text file is made up of a bunch of characters, it makes sense to have something like a delimiter, which we saw earlier on when we got into more advanced stuff that we can do with Scanner. So that enables us to tokenize this file. So we can store 5 distinct values in the file and have some separation between them. A binary file, we don't have any of that. There's no inherent meaningfulness to any particular value. Empty space could be a 0. Actually, space, the character space is not the 0 character, but it could be a space in a binary file. The character that actually ends up being space could be whatever the value of space is, or it could be a literal space. We don't know. Well, hopefully us as the programmer, we know, but as a stream, as a binary stream reading a binary file, there's no inherent meaning to a space character being there. So, how do we actually read from files? Let's start with reading. The book starts with writing. Let's start with reading. So, let's start by turning off half the lights. Getting ahead of myself. Public class fun with files. Let's see. There is a file on all Unix systems, not Windows. Windows is the oddball in this respect. That stores the usernames, the user IDs, and some other additional information about every user that is local to that system. So these machines, they all get their authentication information from some server somewhere else down in the basement over there. So those usernames wouldn't appear on these machines. But all local users are listed in this file. And that file is called, oh geez. I don't know what language I thought I was writing there. Okay, there we go. Read Etsy password. It is called Etsy password. This file name will not work on your machine. I guess I could use my Etsy host file, but I don't remember where the host file resides on Windows. There is a corresponding file on Windows, but I don't remember what it is. Let's see. I think there's actually, we can do something completely different. And start by hoping that Chrome actually runs on Mountain Lion. There we go. There we go. There should be some text files from when I did this in the Visual Basic class last semester. Yeah. Here we go. And I think we can actually, we'll do that exact project in Java. Here we go. USPres and VPres. So I'm going to download these files. I recommend putting them on your machines. So go to the course website, take off that last bit of slashes, or you can see the URL here. Change CS1150.1206 to CS1070.1201. Scroll down to the bottom. Well, I guess it's down by assignments. And somewhere out in the middle of nowhere, there's a link for uspres.txt and vpres.txt. I recommend downloading these files to whatever your user drive is. ZH, whatever it is. That'll make it easier to get to from Java. I don't have OS 10 doesn't do drive letters. So I'm going to save these files to a place where I know I can get to them very easily. Yeah, eventually. So you might as well get both of them right now. You're on the visitor wireless, right? Yes. UCCS Visitor has an irritating habit of blocking all subdomains of uccs.edu. Just follow along, and we'll see what we can do. Okay, so now we can take a look at what's actually in these files. Here's a list of all, it's up to date. All of the U.S. presidents, all, what are there, 45, 42 of them, 45, 40, let's see, let's find out. 43, all 43 of them. And similarly, we have a file of, yes, open up on the other screen. A list of all the vice presidents ever. And that includes presidents who had different vice presidents for the first term and second term. Weird sort of things like that. Right, so that's always a good place to start. So we're not reading etc password. On my machine, I saved them to a special directory on Unix machines called /temp. Oh, by the way, Windows, I've talked about the different line endings, line terminating characters, right? Between Windows and every other operating system. So Windows uses the character turn line feed character. So it's a \r and a \n. Every other operating system, because every other operating system is now Unix based, uses just the \n character. So downloading these files will result in, if you try to open it up, it'll look kind of weird. It'll look fine if you click the link and view it in Internet Explorer, but if you download it, it'll be all one line. To fix that, open it up in WordPad? Yes, open it up in WordPad. Don't do anything to it, just click Save, close WordPad, and then when you open it in Notepad, it'll look fine. WordPad knows how to understand those new line characters, and when you save it without making any other changes, it basically just writes out the file again, putting the right line terminators there. Right, so back to where we were going. Let's read in this this text file, and so for now, I'm going to use an absolute path. On my machine, it's going to look slightly different from on your machine because my machine does not have drive letters. For you, it's going to be something like, what is the drive letter that's associated with your user? Z? It is Z. Okay. Something like that. oh geez. Something like that. You have to escape the backslash. In Windows, the separator between pieces of paths is the backslash. Backslash has special meaning within Java strings, so you have to escape it so you get an actual backslash in the path. And if you saved it directly to the root of your user directory, that path will work. Otherwise, you'll get all sorts of crazy exceptions when we actually run this program. So I'm going to create a new variable of type scanner called precedence. And we need to tell Java we actually want to use that class. So we'll create that variable. And in the past, we've done something like that, right, with the proper capitalization. But here we don't want to read from keyboard input. We want to read from this uspres.txt file. So how do we do that? Without looking at the documentation, we can take some guesses. This would be one guess. However, there is a version of scanner that takes a string in its constructor, and then it becomes a scanner on that string. So it allows you to tokenize strings. You can read through that string as if you were reading from keyboard input. So here, with this, if I did precedence.next, it would give me that next token. If I had something like that, I could do precedence.nextInt and then precedence.nextInt again, and I would get 4 into. That's not what we're looking for. We don't want to scan a string. We want to scan the actual file. It turns out that there is a class called file, which allows us to create a new instance of an object that behaves like we would expect a file to. And there's a constructor to scanner that takes a file as its argument and creates a new scanner on the contents of that file. Somehow. We don't really care how. But in order to create a new file, we need to tell it what the underlying file actually is, and we can do that by specifying the name to its constructor. So here, we will do temp uspres. Am I missing? No, I have an extra one. Okay, so now that we have a scanner that will read the contents of that file, we can do scanner things. Since each line in this file is a useful unit, we'll treat each line as the smallest piece. So we'll go line by line, and for now, do something with it. How do we do that? It would be really nice if we could do something like for, I don't know, string do something. Unfortunately, we can't. But we can get pretty close to that. We can't actually use a for loop. We're limited to using a while loop. Which means that we have we need some sort of condition here. Turns out Scanner provides several Boolean methods for us. And they all start with the word has. And the remaining part of the method is exactly like the text that forms the methods of type next something. So there is a has next method that just indicates if there's something else there. There's a has next line method that indicates if there's essentially the same thing, if there's more to the file. Has next int, has next double, all those sorts of things for exactly the same reasons. Here we'll do has next line. And that basically says if there's more to the file, we continue looping. Otherwise, we stop looping and do something else. But that doesn't actually get us that next line. In order to get that next line, we have to say we actually have to call next line. And I'll store it in a variable that I'm calling a line. Hey, the book's calling it line too. We actually agree on something. And all the book is doing here is printing it out. We have most of the functionality we need in this program. It's always a good idea to specifically close your files. So when you're done reading from a file, close it so that it's actually you're deallocating resources. The operating system likes you for that. It becomes an issue if you're reading from a bunch of files, and if you open a bunch of files, start reading from them, and never close them, eventually the operating system says you're not allowed to open any more files. You already have 17 million open. You're done. You're cut off. So if you want to continue opening more files, you should close the ones you're done with. So there's a close method just for that. So now all the functionality is here. We can try to compile it. And it will complain because we don't know what file is. Another thing we need to import. File is in a package called java.io. Java.io contains a bunch of classes useful for doing input and output. We'll see some now and some when we talk about writing to files. And now we get an error that we have never seen before. Unreported exception, java.io, file not found exception. Must be caught or declared to be thrown. This is why we talk about exceptions before we talk about file I/O, because file I/O requires that we deal with exceptions, or we provide some mechanism to deal with them. And if you look on page 738, which is basically the same example, you can see there is a try-catch block that catches file not found exception. And that's exactly the exception that is complaining that we're not handling. So let's do that. FileNotFound exception is also in java.io, so we have to import that. Java.io. And we should probably do something in here. Now we also have the issue that this is inside the try block and we want to use it outside of it. So move our declaration of variables up here. And the book also has a system.exit in here. Remember what I said last class about system.exit? I don't like it. It doesn't feel as nice as other ways of exiting. So I'll just return from the main method. And now it compiles. Before you try to run this, make sure that your path, the path you specified for the uspres.txt file, actually corresponds to where you have it downloaded on your computer. Otherwise, you will exercise this exception handling code. So, for instance, that is not where the file is. We'll compile and run eventually. And it will say no file. However, if I give it the right path and file name, we get the entire list. Questions on reading from files? You can, but Java irritatingly does not have anything as nice as link. So, yeah, let's do that. And that'll actually help us transition into writing files. So let's let's print out every president's name that starts with the letter B. So we'll put an if statement in here. If line dot char at 0. That gives us the first character. Equals letter B. Then we'll print it out. And we get 3 names. If we wanted to be really, really, really creative, we could print out every president's name, every president whose first name is George. There are at least 3 that I can think of. Yes?
Why you're doing the B, starting at B, why do you use single apostrophe?
Because it's one of those literal things. So in order to specify this is a character, I need to put single quotes around it. Otherwise, it interprets it as a string with only one character in it. And being a character, literal, not a string, means that I can use the double equal sign on it. Because it's a scalar value. So that's get presidents whose first names start with B. How do we get presidents whose first name is George? The easiest way to do this, there are several ways to do this. One way is to look for a space in the name, split the string on that space, or get the substring before the space, and then compare that to see whether or not it's George. An easier way to do that is to use another scanner. I will call this parser because that's basically what we're doing. We're parsing this line to get the first piece out. Equals new scanner. And now we're going to use the other variety of scanner that I mentioned before, the one that scans a string. And the string that we want to scan is the line we got from the file. And we can say something like if parser dot get next. No. Parser dot next dot equals George. Print out the name. And to be nice, what am I missing? Oh, that's what I'm missing. To be nice, I will also close this. Questions on what I'm doing here? No, that closes my scanner called parser, which is parsing just a string. So it's deallocating resources that are allocated to that particular scanner, which end up happening anyway when the loop restarts because that variable goes out of scope. But so we'll compile and we'll run, and we get 3 names. Okay, so now let's go from not just reading from a file, not just getting some useful information out and printing that to the screen, but write that back out to a file. And this is accomplished using something called a Printwriter, which is actually very similar to what system.out is. So let's see. What I'm about to do could also cause a file not found exception. Which is kind of odd, because if we're writing out to a file, it really shouldn't matter if the file exists or not. If the file exists, we just clobber it and start writing again. If it doesn't exist, there are no issues. We're not losing anything. So let's call this out. Well, I can spell output. Here's an example where having one try-catch block, well, you could go either way. Both of these statements could cause the same exceptions, so you could group them together in the same try-catch block, but you might want to print out different information depending on which file can't be found, in which case you could put them in separate try-catch blocks. I'll put them in the same one just to make my code shorter. This should not be a scanner. This should be a Printwriter. Printwriter, because strings are immutable. Strings cannot change. So it doesn't make sense to have a Printwriter that writes to a string. So if we specify a string to Printwriter, there is a constructor for a Printwriter that uses the string that's passed in, assumes it's a file name, and uses that as the output file name. So we'll use that. And I'll call it output.txt. You can change this in exactly the same way that these two paths are different to make it write to the root of your student drive. Now that we have the Printwriter, we don't have to do anything else in order to use it. We can just use it directly. And let's look at the documentation for Printwriter real quick. Oh my. What happened here? Apparently Google Chrome and Mountain Lion don't get along in terms of the cache. Reload frame. There we go. Okay. So we can specify a file, and a string, output stream, a whole bunch of stuff. This is the constructor to Printwriter that we're using, specifying a file name. And if we look at this section of methods, they're all the exact same methods that we have that we can use on system.out. There's a very good reason for that. System.out either is a Printwriter or it implements the same interfaces as Printwriter. So that means we can use println. That will be useful. We can just replace system.out with output. And likewise, when we're done using that file, we should also close it. So now this program will read in a list of all the precedents, search through each one of them in turn, basically go line by line in the file. If the first name is George, it will write out that name to another file, otherwise it'll just go on to the next one. Yes, I do. That should be semicolon. Ah, yes. Cannot find Printwriter. Any guesses as to where Printwriter is? So we didn't print anything to standard output, so it doesn't show anything in the interactions pane. However, if we pull up output.txt, the output is there.
Well, I think mine probably begins with I've got a file that it's
Okay. This is one of the, especially with writing to files, close is very important. Calling close is very important. I skipped over it very quickly, but if you notice here, the description of this constructor creates a new Printwriter without automatic line flushing with the specified file name. Automatic line flushing means as soon as you write something to that Printwriter, it goes directly to the file. Do not pass go, do not collect $200. No stops, it goes directly to the file. Most of the time, Printwriters do something called buffering. So if you're writing a bunch of stuff to a file, it'll accumulate all the stuff that you're writing, or a good chunk, keep it in memory, and then eventually, periodically, write that stuff out to file. The reason for doing that is because memory is a lot quicker than files. Disks, even though to us disks look really fast, disks are really slow when compared to memory. So if I add a name to this Printwriter and it goes off and writes to disk, the program has to wait for that to happen before it can continue. With buffering, it can write a bunch of stuff to memory, and then eventually, when it hasn't written something for a while, all of the stuff in memory can go to disk, so it doesn't slow down the program as much. This raises the question of when to flush. Printwriter has a method somewhere in here called flush that you can call manually to make that happen. It also gets called when you close the file, because close says deallocate all resources, which means that in order to take anything that is used for that file out of memory, you don't want to just lose stuff that's still in the buffer. So it does this flush procedure and takes all the stuff in memory, sticks it in the file. So, long story short, your file is not getting closed. So when the file disappears, it just disappears. It gets garbage collected, nothing additional happens. So anything that you have written to the file but has not been flushed, anything you have written to the stream but has not been flushed to the file, just goes away.
So should I do parser.flush and then it would do it?
No. So it's not parser that's doing the output. It's output that's doing the output. So you're missing that line. Any other questions? Cool. So I think at this point we'll take a break. I'm actually on time today. And the reason that I'm on time is because I want the activity for today to be to continue this program, and instead of just taking the US presidents, searching through them and picking out select ones, sending that to output.txt, let's extend this program to read in all of the presidents and at some point all of the vice presidents. And what should get written out to output.txt excuse me, is all of the presidents who are also vice presidents. And there are multiple different ways to solve that problem. There are ways that involve storing the entire list of one or the other. And if you want to use that approach, you may find the Java class called Arraylist to be useful. You can look up the documentation for Arraylist, and if you Google Arraylist, you will probably get more resources than you can possibly fathom. Arraylist is basically an array that handles its own resizing, so you don't have to worry about how many elements you have. The other option is to have inside your while loop that loops over the presidents, you open up the vice president's file and loop through it and see if that president is in there. Close the file. On the next iteration of the loop, you do the same thing. On the next iteration of the loop, you do the same thing. That approach is slower, but you don't need to look up anything additional to do that. All right, so break time, and we'll reconvene at 12:10.